We are about to start chapter 4.6. Let me go ahead and open up my tablet here. 4.6 is optimization. And it's going to kind of bring together the practical use of everything that we've been doing so far. Strategy, let's come up with a strategy here. Strategy for solving optimization problems. And when we speak about optimization problems here, we are primarily referring to how to maximize things like revenue and cost and, basically finding the vertex of a parabola that's turned upside down. Step one would be to introduce variables by looking for relationships among the variables then constructing a math model of the form or information that we're given. Then the second step would be to find critical numbers. And we would do that by taking the derivative and setting the derivative equal to 0. Use the process from 4.5 to find extrema. And then the fourth step will be to use the model the function that we created to answer the question. So all of this just seems kind of abstract until we look at exactly what we're doing here. So I'm going to immediately open up the homework here, and we're going to copy and paste the first problem. Okay, this is the first homework problem here would be this one. I hope it's still copy and pasted. Let's go ahead and see if we can put it into the sheet here. Yes, here it is. Find two numbers whose sum is 8 and whose product is a maximum. So first step would be to say let the two numbers be 8, and the next number would be x minus 8, because the sum of the two numbers x, the sum of the two numbers would be 8. So if one number is x, then the other number would be that would be 8 minus x, not x minus 8. 8 minus x. So our model that we're going to construct, P of x, the product, x into 8 minus x, and then we distribute this, and we can see we have negative x squared plus 8x. Now we want to go ahead and find a critical number by taking the derivative, which is negative 2x plus 8. And when we set this equal to 0, we get x is equal to 4. This is the critical number. Critical number. So we probably want to do a small line here, because we're going to test values. We have 4 here, and we're testing, so a number less than 4, so let's test 3. Into the function, we have a positive number. When we substitute it, we get negative 2 times 3, which is negative 6 plus 8, to give us a positive number. And substituting a number that is greater than x, then 4, which is probably 5. Remember, the two numbers have to be between 0. Well, it didn't specify that, so we're just going to leave that alone. Testing 5 in here, we see negative 2 times 5 is negative 10 plus 8, which is a negative number. So this means that it's increasing and then decreasing, increasing, decreasing, so a max at x equals to 4. So the two numbers then are x is equal to 4 and 8 minus x is equal to 8 minus 4, which is also equal to 4. So the two numbers are 4 and 4. Kind of gives you an idea that the two numbers that we're looking at are 4 and 4. These two numbers, when we multiply them, we get 16, are the two numbers that we're looking for that would maximize them to give an answer for us. Let's look at, this is a reasonably straightforward problem. Let's look at another problem here. So we're going to open this and snip the outer problem here. This problem has a whole bunch of parts. So we're going to try to answer all of the questions offered by this problem. Let's paste this problem into the sheet. And you see, a company manufactures and sells Excel phones. Can't take that out. Per week. The weekly price, demand, and cost equations are given by the function P 400 minus X, and C of X equals to 2,000, the cost and the price, 2,000 plus 135x. At what price should the company charge for the phones? And then how many phones should be produced? And then what is the maximum revenue? So we're going to go ahead and start by writing out the revenue equation, because they're obviously talking about the revenue here. So part A, the revenue is equal to X times the price, okay? Which in this case is X into negative 0.5X, 400 minus 0.5X. Okay, remember they're talking about revenue here. This is what I'm emphasizing. So this revenue is equal to negative 0.5x squared plus 400x. Now we're going to go ahead, because they're asking us about the maximum revenue. So we're going to go ahead and take the derivative. R prime is equal to 2 times 0.5 is 1. So this is negative x plus 400. And then if we set this equal to 0, we get the critical number x is equal to 400. And that would likely be the maximum point. Let's go ahead and check it. If we take a number that's less than 400, perhaps 300, and a number that's greater than 400, perhaps 500, and substitute back into the R prime equation, we get negative 300 plus 400, which is positive, and 500 minus 400, which is negative 500 minus 400, which is negative. So this has a max at x is equal to 400. And of course, this is the absolute maximum point, because this is a quadratic equation. So next we're going to go ahead and answer the question here. They want the price. Recall that the price is negative 0.5x squared. So x, hold on, the price is 400 minus 0.5x, that's given. And we're going to substitute in here. We get 400 minus 0.5 times 200, which is equal to $200. So the maximum revenue, we're going to go ahead and substitute the quantity back into the revenue. So far we've answered the maximum occurring at 400, the price is 200, and the revenue is, we use the revenue model here, 0.5, 400 squared plus 400 times 200. Head to your calculator and you'll see that comes out to $80,000. So what this is saying is the company should produce 400 phones at a price of $200 each for a maximum revenue of $80,000. Next, we look at Part B. What price should the company charge for the phones and how many phones to maximize the profit this time? So now we need to understand what profit means. Profit is equal to the revenue minus the cost. Okay, so this is from the information that we're given already, 0.5 x squared plus 400 minus the given cost function, which is given in the problem, 20,000 plus 135x. So we distribute the negative here. We have 0.5 x squared and with that, I'm sorry, this is 400x, right? 400x. So plus 400x minus 135x minus 20,000, which is 0.5 x squared plus 265x minus 2,000. So we have to find the critical number here. We will take the profit. I'm not using P here because P is already used for the price. So profit point is taking the derivative here. I think this is a negative sign. Yes, yeah, this is a negative sign. Apologies, that's a negative sign. So this is negative 1x squared for the first derivative plus 265. Negative 1x plus 265, logically implying that the critical number x is equal to 265. And we solve that and we set it equal to 0 and solve it. So again, if you test this, you're going to see that this is a quadratic equation, so we don't need to do much here. This is 265. If we test a number that's less than 265, let's say 260, we get positive here, and greater than 260, the profit prime function becomes negative. So absolute max at x is equal to 265. Because this is a quadratic function, that would be the only maximum point. So we go back now to the profit function. To the profit function and substitute. Hold on, they want the price first, right? Yeah, they want the price first. What price? So my apologies. We don't have to do the profit function as yet. So we would find the price. We would use the price function, which is 400 minus 0.5 x, and substitute x as 265 in here. We get 400 minus 0.5 times 265 which is equal to $267.50. And then, oh, they do want the profit. So for the profit, we would use the profit function here and substitute into that negative 0.5 times 265 squared plus 265 times 265 minus 20,000. This is 20,000. 20,000. Put it into your calculator, you get $15,112.50. So the company should produce 265 phones each week at a price of $267.50, or a maximum profit of $15,112.50. I'm going to go ahead and copy the next problem, all about sandwiches, and put that into a one-more document. So deli sells 320 sandwiches per day at a price of $4. Market survey shows that for every 10 cents reduction in price, 40 sandwiches more will be sold. How much will the deli charge to maximize revenue? So we have to identify some variables here for part A. Let X equal to the number of sandwiches at 10 cents reduction in price. And so it's not the number of sandwiches, but the number of reductions, the number of 10 cents reductions. So let's write that back. That's not worded correctly. The number of 10 cents reductions in price. Now the number actually sold at 10 cents is equal to the 320 original sandwiches plus the 40 given here, times x. Okay, that's because it's 40 more sandwiches will be sold. How much should the deli charge to maximize the revenue? So price per sandwich is the $4 price minus the 10-cent discount times the number that is sold at the reduced price. Now, keep in mind that x has to be greater than or equal to 0, and x has to be less than or equal to 40. They can't go more than that. So x is going to be a number between 0 and 40. So revenue, right? Revenue, because we're talking about maximizing revenue. Revenue is 320 plus 40x times 4 minus 0.1x. Right, the price times x number of how many number of sandwiches instead of we're just using the revenue equal to the price times x, but x in this case is 320 plus 40x, and this is of course the price. So the price times, if you wanted to do it this way, would be number sold times price. That would be a better way to look at it. So you would have to FOIL this out in order to take a derivative here. That would be 4 times 320 is 1280. First outside plus 160x inside and less. 40 times 0.1 is 0.4x squared, 0.4x squared, yeah. 4x squared, yeah, 4x squared. About 4x squared. So collecting like terms with 1280, 160 minus 32 is 128x minus 4x squared. Then taking the derivative here, we've got r prime x is equal to 128. Sorry, this is negative 4, so negative 8x plus 128. So our critical number x is 128 divided by 8, which is 16. To do this, we would have to go ahead and test some values. Remember, the prices here can go from 0 to 16. And then to 40. Actually, you don't need to do all of that. We already know what the price is. The price is equal to 4 minus 0.1x. So 4 minus, and we found x to be 16, 0.1 times 16, which comes out to be, if they calculated, $2.40. Using my calculator on the side here, you can't see it, $2.40 per sandwich. Okay, if you wondered what I was talking about here, because we have to consider R0, R16, and R40. So these 0 and 40 are the two endpoints. So if we substitute 0 into the original equation, which is this one, we substituted 0 into this, you would get 1280. If you substitute 16, you would get 2304. And if you substitute 40, you get 0. So remember, this is the maximum. Max occurs at x is equal to 16. So we didn't really need to do anything else. You could do the number line and check, but there's no need to do all of that. So $2.40 for maximum revenue. Then part B, 20 cents reduction, 10 more sandwiches will be sold. So the same type of problem, except the numbers are different. So number of sandwiches, we're not going to write back everything this time. The number of sandwiches is 320. 320 plus 10x. It's not 40 this time, 10x. Okay, 10 more sandwiches will be sold. And the price is 20 cents less, so 4 minus 0.2x. Okay, I want to see that x here would represent the number of sandwiches that are sold at the reduced price, right? So at this time, keep in mind that the x has to be between 0 and 20 this time. Okay? Let's go. Let me go back and look at this. Yeah, 20 cents reduction, 10 more sandwiches. So x has to be a number between 0 and 20. Back to here. Row 2. Oh, so it's 0 to 10, right? 10 sandwiches more. Yeah, my bad. 10 sandwiches more. So x would have to be a number between 0 to 10. Now, the revenue, again, we have the same equation, 320 plus 10x, 4 minus 0.2x. Foiling with that, 1280 plus 40x minus 64x minus 2x squared. Yeah, minus 2x squared. 20 20% of 10 is squared. So this simplifies to negative 2x squared minus 24x plus 1280. And then r prime is equal to negative 4x minus 24. So this is telling us that the critical number is negative 6, which is not possible because it falls out of the domain when we think about that. It falls out of the domain. So no. So the only two possible numbers that we have are R0 and R10. That makes it equal to 10. So testing R0, we would have, substituting R0 into this equation, it gives us the x goes to 0, so exactly 1280. And then substituting 10 in here, let me put that into my calculator to see exactly what it comes out to be. Negative 2 times 10 squared minus 24 times 10 plus 1280. That gives 840. So the maximum occurs at 0. So the price at 0 and x is equal to 0 is 4 minus 0.2 times 0, which is equal to $4. Kind of a tricky problem here, and I'm a little confused about something here. I have to look back at this here, which is the domain somehow does not make any sense to me. I'm wondering if the domain is correct. Let me check this. I'm talking about this domain here. Should x be between 0 and 10? And on the surface it seems to be correct, but something is not making sense with it. Problem is telling us 10 more sandwiches. Yeah, so x cannot be more than 10, so that makes sense. And then if we substitute 10, negative 2 times 10 squared minus 20 times 10 plus 1280, so $4. So I'm gonna go with that. I'm gonna go with that. Our rental agency rents 400 cars per day at a rate of $40 per day. For each $1 increase in rate, 10 fewer cars are rented. At what rate should the cars be rented to produce the maximum income, and what is that maximum income? Very similar to the first one, so to the previous problem. Let's go ahead and write this out. Income equal to the price per day times the number of cars rented. Then let X equal to the number of $1 price increases that occur in a given day. So price is equal to 40 plus 1 times X. And then the number of cars so we started with 440 cars, 10 fewer rented, so negative 10 times the number of dollar price increases, which is X. So maximum income, let's go ahead and identify a variable here. Maximum income or revenue is the price times times what is termed as X here. So this is 440 minus 10X plus 40 plus X. And then distributing here, we get the distributing part 17,000. 440 times 40 is 17,600. Outside and inside, negative 400X plus 440X minus 10X squared. And then collecting the middle terms and rewriting this, you can see that this is the proper quadratic equation. And then taking I prime here, I prime with that negative 20X plus 40. So setting this equal to 0, we see that the critical number X is equal to 2. So remember that for the purpose of our class and this problem, that we need to figure out the domain. So note that $440 minus 10X is greater than or equal to 0. So if we solve this out, X has to be less than or equal to 44. I think this is where I had that little mistake in the previous problem. I'm always getting confused with it. I'll go back and look at that in a second. So we've got 3 parameters here. Okay, we've got, because this has to be between 0 and 44, and then we've got a critical number of 2. So we can test all 3, F0, F2, and F44. Remember, we tested 2 endpoints as well as everything in between. So we're testing in that equation. We've got F0 given 17,600. Substituting 2, we get 17,640. And substituting 4, we get 0. So obviously this is the max. And the price at the max is 40 plus X, which is 40 plus 2, or $42. And so max income of $17,640 at $42 a day. Yeah, this is what I wanted to go back here. I didn't calculate the domain. I know I did something wrong here. This is the domain should not be 10. It should be 20. Not bad. It should be 20, not 10, because 4 minus 0.2x has to be greater than or equal to 0. And if we solve this, we see x is less than or equal to 20. So the only difference it would make here is when we substitute 0, when we substitute 20, the answer would still be the same. You would get 0, not 840. So they didn't ask us this, but it's not bad right there. It has to be between 0 and 20. So when you go back to this problem, you'll see what I'm talking about here. In any case, the maximum therefore of r is equal to 0. Fence problem. Fence is to be built to enclose a rectangular area of 1,250 square feet. The fence along 3 sides is to be made of material at $3 per foot. The fourth side is $9 per foot for some reason. Maybe that's the front. So we're going to identify sides, so X and X and Y. And we're going to cost this out. We've got 3 of the sides at $3 per foot, and the fourth side at $9 per foot. So this means that 6x plus 12y, 6x plus 12y would be our cost function. We're also told that the maximum area x times y is 1250. So in order to minimize the cost, thinking into this, to minimize c is equal to 6x plus 12y, or xy equal to 1250. We will need to rewrite this in terms of one of the variables, so y is equal to 1250 over x. So we would make that cost function. See how much fun this is. C is equal to 6x plus 12 times, in place of y we put 1250 over x. That substitution right there is made right there in place of y. So cost is equal to 6x for 1250 plus 1250 over x. Distributing with 12 times 1250 is 15,000. And we will of course need to take the derivative here, so this is 6x plus 15,000 x to the power negative 1. So C prime is 6. And if we bring the negative 1 to the front, it becomes negative 15,000 x to the power negative 2, which is 6 minus 15,000 x, x over x squared. So I'm going to go ahead and set this equal to 0 and see what the solution would be. This is 6 minus 15,000 over x squared is equal to 0. So multiplying everything by x squared, we have 6x squared is equal to 15,000. So x squared is equal to 15,000 divided by 6, 2,500. X is the square root of 2,500. Now, you can go ahead and argue that the 50 is the maximum point. This is a quadratic function anyway. Quadratic function anywhere. So if you wanted to test this, you can go ahead and pick a number, say x is 40 and x is 60. And if you substitute it back into this, you get minus, 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 minus. Okay? That's 6 minus 15,000 divided by 40, which would be a number that is larger than 6, negative 6, and then this would be positive. Remember, you're substituting back into this here. You're making your substitution back into this here. Okay? So you can probably check that out for yourself. So, sorry, this is a number 60, not 6. Just to check it, 15,000 divided by 60 squared, 4 points. So 6 minus 4 is positive, and then 15,000 divided by 40 squared gives 9 point something. So 6 minus 9 gives a negative number. So this is a minimum point. Min at x is equal to 50. And since this is a quadratic function, the absolute min is x is equal to 50. And we know that the y value is 1250 over x, which is 1250 over 50, which is equal to 25. So the long side would be, the short side would be 25 feet. Long side would be 50 feet. And finally, question 6. publishing company sells 450,000 copies of a certain book each year. It costs the company $1 to store each book for a year. Each time it must print additional copies. Every time they print additional copies, it costs the company $1,000 to set up the presses. How many books should the company produce during each printing in order to minimize its total storage and setup costs? So we need to set some variables here. Let X equal to the number of books each printing. And then we have to consider the production runs. Production runs, R-U-N-S, are in terms of X. R would be equal to the 45,000 times the number of books produced every time the production is run. So see that the number of books has the domain for this X here has to be between one book and 450,000 books. Okay, that domain is easy to see. You don't have to worry too much about that domain because they can produce a minimum of one book and a maximum of 450 books. Next, we have to think in terms of the setup cost because there's a $1,000 setup cost right there. So we have to consider that $1,000 setup cost. So setup costs would be the number of runs, every time they set up to a printing times $1,000, which is what? A large number. 450 million divided by X. One other thing to consider is the average storage cost. Is equal to X over 2 because they said that the storage cost is $1 for each year. So the average is half of that price, half of the number of books each printing. Because we can't take it for the whole year. We have to take an average storage price. So the total cost is the average storage cost plus the setup costs. So in other words, this plus this. Fun. So this is X plus 2 plus 450 million over X. Okay, this is C. So C prime. Okay, this is half X, so taking the derivative of half X, we are left with half. And the derivative of this here, I'll let you guys go through the process of that, 450. If we bring X to the top and then take the derivative, the sign will change to negative over X squared. Okay? So we would need to go ahead and set this equal to 0 to find that critical number. So 450 million over x squared is equal to positive half. If we multiply both sides by x squared and both sides by 2, we would get x squared is equal to 2 times 450,000, which is 900 million. So x is the square root of 900 million, which is exactly 30,000. And all you would need to do now is to confirm that this is the maximum. Zero 4,500. I'm sorry, 450 million. So test values, perhaps testing 1 in here would be pretty fast. If we were to substitute 1 in here, x equal to 1. And remember, you're substituting in this, okay? So half minus 450 million divided by 1 is clearly a negative number. And then something over 30,000 would be, I don't know, 40,000. So substituting 40,000 into this will give us a positive number. Remember, when you're doing your substitution, make sure that you're substituting in that. Okay? Always substitute into this cost line. So this printing company should produce 30,000 books. Okay, guys, have this, and then it is right now. This was a long video.